to talk a little bit about what makes a good lightning talk at SciPy. SciPy lightning talks are not necessarily the same as lightning talks that you've heard at other conferences. Lightning talks can be really well prepared if you want them to be, but they also can be something that you come up with at SciPy. Maybe you see something cool in a talk and you're like, I want to try that. Maybe you just have like a bunch of dog pictures you want to show, and then you make a collage with Matplotlib that's like some special processing of all those dog pictures. Whatever. You can do that. It's great. You should sign up for lightning talks. But we decided we're going to kind of show you something that we hacked together for our lightning talk. But just know that you don't have to make it super well prepared. And so to demonstrate that, we're not very well prepared. So enjoy.
This is very hacky too, which is great for lightning talks. And I'm taking the blame of being old schooler here. But yeah, we will show you the details.
You're taking the Git blame for that?
I have to take it, yes.
Okay, so some of you have seen the t-shirts that we have, right? And there's not ads on the back of them, but instead we have some code that's related to some puns. So the SciPy Lightning Talks, for those of you that are first-timers, usually are accompanied by some people in the front who like to comment on your talk after it's over with puns. And so we thought it'd be fun to make an allusion to that on the back of the shirt. So when you saw that, what did you think?
Does it work?
Yeah, does it work?
It didn't.
It didn't because it didn't exist, but it didn't exist on PyPI either.
Yes, and we are in the Pacific Northwest, so what we really love to do here
is camp.
Camping, yeah. So I camped on PyPI on these. And then totally forget about it. So we arrived at SciPy. Did the t-shirt work? No.
Yeah. So then we decided to hack it together today. So we decided to make a package, a pun package. So this is a live demo, which is, of course, the most straightforward of lightning talks. It always goes well.
Yeah. No, it's not even a live demo. It's a live release.
Oh, yes, yes. So yeah, so do you want to demonstrate how it works?
I think I have to. Yes. Yeah.
Yep. So it's under the SciPy conference organization. It's the Puns SciPy conference repo.
And this is really full of not best practices. That's intentional. The documentation is at the back of your t-shirt. If you don't have a t-shirt, then grab a t-shirt and that's your documentation. Okay, so you can comment why I'm releasing. The old school way, there are no bots involved. I am the bot doing everything manually.
Yeah, so we're doing I'm releasing the Brigida bot.
No, I think we are also in Seattle.
Release the Kraken.
Yeah, releasing the Kraken.
Yes, exactly. Oh no, the claw. Yes. Exactly. Okay, so you're doing a live release because we had a pull request from Eric, who had a lot of great ideas on the repository. And so he added some extra new puns. He added a JSON file. So you can all submit pull requests to this repository of puns that you hear at the conference that you think are cool. So it's gonna house all these cool puns, and then we have a history of SciPy puns that people can look up. Yeah.
Are you using distutils?
I do. I said that I'm old schooler. There are no warnings. There are no problems. It's installable. And it still works.
We had a question of who is Jason?
I don't know. I don't know how to deal with those files. So I pulled in and opened it with AstroPy. So... Yeah.
So does that mean I can submit a fits pun?
If it fits.
Okay, well, you got to do we have like 1 minute left. Are you going to get this release done in 1 minute?
The release is done. It's already installable.
Okay.
I just have to type IPython and find where my terminal is.
Maybe make it a little bigger.
Oh,
like
even
the text.
Bigger. All these.
Zoom and enhance.
Okay, so it's from SciPy conference, import create puns. but
It's not like we planned that at all.
so there are a couple of puns in there, not too many. Please.
And
open
thank
for
you
it.
so much.
Yes.
Yay.
It's like a DJ.
All right, next up, we have Deborah Carter. While she's getting set up, we will pull someone else to come.
Yes, exactly.
we already have it.
Where would you like this to be?
Subosit Ray. Fantastic. Be on deck.
Mike? Hot mic?
Deborah, would you like to punish yourself, or would you prefer to give us clean?
You know what? I need my hands, so I'm not going to
Okay,
punish
that's
myself.
totally fine. That is totally fine.
All right. So I'm Deborah Kider. I'm going to talk about a assistant for paleoclimate research, an AI assistant for paleoclimate research that's based on a RAG system looking at all the work that we've done for paleoclimate. So in terms of looking for at databases, but also running code. So this is an example of we have 3 agents, one that does Sparkle, so queries for the graph database, querying data sets, one for code, and one that tries to do complete workflow for the scientists that they can actually just have a look at their result. So the Sparkle one, we're just asking it, for example, to show me all the data set in the compilation. It runs, essentially, it writes the code for you. If you're not happy with it, and if you know what you're doing, you can actually go back and edit as you wish. So the idea here is it gives you a backbone of what the query should look like, but then you can actually build on this on your own and rerun as you want. Once you have the data sets, I'm not going to fetch all results here, but it actually fetches at 10 at a time. You can actually say, okay, show me the lat long for it. And if you do this, it gives you a nice little map of where the records are. You can actually click on them. You can actually browse what the data set looked like, have a look at it, the location, what data is in it, things like this. And you can actually download the file on your own computer if you wish. If you actually tell it, also tell me what archive it was measured on, then it changes the symbol and tell you exactly if it's a speleotherm, if it's a lake record, a marine record, things like this. So the idea is to actually make it very easy for scientists to have a look at their data. So now I'm going to switch a little bit to the code/workflow agent. So in going back to discussion, at the beginning of discussion, I'm like, can you just open this file for me? So I know this is technically data, but it's just an opening a file. So it's a code agent that does this. So it actually just grabs the data, write the code for you. Again, you see the code. The idea is to actually kind of teach you as it goes, and then shows you the results. And then you can actually ask it, for example, what type of data is in there. Can you show me what's in the file? And again, you can actually kind of create that column, that data frame that looks at your data. Ask it what type of variables is in there by looking at that the column that you want, and looking at the unique entries, and then essentially look at all the information for that variable, and keep going and essentially go to code so that you can have a better look at the data. Ask it to plot the time series. So here it goes to give you a plot of that core data set over the past 1,000 years or so. And then you can actually start going into more of the workflow part to it. So I'm asking it just to pretty up the plot here. But here I actually wanted to run spectral analysis. I know that to do this, I'm going to have to actually segment this out a little bit because there is significant gaps in the record. And I wanted to use a technique called MTM. What it will do is actually plan it out for you. It will tell you what the plan is, and you can actually edit the plan. So I've run this, but if I was doing it live, you would be able to edit the plan if you're not happy in English. We're actually going to build a Q&A to actually kind of ask it, why did you choose this? What parameters can I change? Things like this. And then once you're ready, you can actually run it, and it will run essentially every single step, telling you what it's doing in that step exactly, showing you the code, and essentially going through the motion. So here it's segmented into those 3 segments. It keeps going into doing that workflow analysis, so running the spectral analysis on all of the segments, giving you a nice plot summarizing the three. And then at the end of the day, the last step to this, it actually gives you a little report of what it did, what it's found, and essentially try to explain what happened, what's been done, what are the caveats, and so on and so forth. So hopefully we're hoping to put this in the hands of the community at the end of the year and see how people actually work with the tool. Thank you.
Thank you. Suspiciously well prepared. Kyle, you're up. Next up on deck, or on deck 2 or whatever, is Tim Swain. Tim? Tim.
I was on this side.
Great, okay.
Thank you.
Kyle.
So
What's
Kyle
happening,
gets
Kyle?
the first spin of the day.
Oh boy. Okay.
It's best to try and just go hard and down. You can
Yep.
give it a proper,
Okay. The claw.
The
The
claw.
claw. So
The claw.
Kyle now has to not only wear the claw, but he has to do crab motions while presenting as well.
Okay.
All right.
Thanks for this.
All right. Good luck.
Appreciate it. All right. So I'm going to talk very briefly about an opportunity. This is actually something that is an opportunity for a lot of people in this room here.
More claw
So-
motions.
More. Okay, I'm sorry. This is an announcement about an opportunity for early career fellowships through an organization, virtual organization called the U.S. Research Software Sustainability Institute, or ERSI. This is something that Nick Weber, who's not here, and I are running this particular fellowship opportunity. So pay attention, because this is a chance for money for you in this day and age of reducing resources. So the mission of ERSI, this organization that we're a part of, is to improve quality, usefulness, and sustainability of research software by improving practices and increasing the diversity of practitioners. We do other things. We run training schools around research software. There's some work on policy that's also being done, but I'm only talking about this one thing. We actually had a first round of fellows. These are 6-month projects to support early career researchers who are working in and around scientific software development and education. One of them is in the room, Matthew. You've seen him up on stage. So Matthew's one of our first 2 fellows, as well as Sam Zhang, working on different projects. They'll hopefully be able to talk more about that later once those are done. We have 3 tracks, so people, it's not just you applying, but you have to submit a project idea for this 6 months amount of funding. The tracks are around AI, ML, and scientific software, so research or evidence-based best practices for integrating these tools into your scientific software development or into community development. Scientific software sustainability, so this is meant to be more around a specific domain of research, or software education research. So one of the things that ERSI does is puts on summer and winter short courses around software development. And so we would like people to also propose ideas around how to do this better, essentially, or how to help us evaluate it. There's a blog post that announces these in a bit more detail, and you can read about those. But your project has to align with one of these tracks. We won't just support software development itself. Okay, it has to align with one of these things. Sorry. Okay, so I'll keep it quick. Just some brief information. So these are open currently for the second round, due near the end of the month on July 25th. It's meant to support early career researchers. So those are PhD students, postdocs, RSEs, or other research scientists who are either, if they're a student, or within 3 years of their terminal degree. It's between $10,000 and $25,000, which includes a minimum of $10K in salary, and then other costs are for other research-related expenses or travel. You can go straight to the application there. Or if you go to the ERSI.us site, you can read more about the eligibility criteria and frequently asked questions and so on. This is very possible via some generous grant from the Sloan Foundation. ERSI itself does not have social media, but if you want to see announcements, you can follow me on Blue Sky or Mastodon. I'll be announcing these things, or just go check out the website. That's it. Thank you.
Thank you, Kyle. Thank you. Tim, can you come sit over there? Suppose you can come start getting set up. And next on deck, we have Yuvi. Yuvi, are you here? Great. Can you please come up? Fantastic. Suppose that you don't have to spin. I will point out if you do spin and you're wearing a claw, for instance, or baby hands, it makes for great LinkedIn profile pictures.
But I'm
Know
fine.
this from experience. You're good? Okay. All right. Then your time has started. Take it away.
Okay, I'm Shubhashit Ray, and I'm a postdoctoral fellow at Florida Atlantic University. And today I'm going to present challenges of model explainability in multi-label classification. So as you know, many of the challenges, many of the studies in healthcare is happening in terms of whether to detect particular disease or particular severity cases. And most of the times these are binary classifiers or multi-class classifiers. Here, we're trying to tackle something called multi-label, where severities or disease can co-occur or occurs in consequence nature. So how do I interpret the black box of a multi-label classifier is the challenge. Okay, so this is how the multi-label would look like. So here I'm analyzing a COVID-19 data set from South Florida patients who are already hospitalized. And over on the left side, you would see severity of condition. So 0 means the condition is absent, 1 means the condition is present. Over here on the right, I have a Venn diagram that looks into the intersection of these subsets of severities. Okay, so once we have that, now my objective of the classifier is to predict this pattern. So what I do is I train 4 different classifiers that would predict each individual classes, but in chain classifier, I can pass on the prediction of the one of the classifier to the next classifier. So there's a cross linkage so that they can address better, and this is just AUC for binary relevance and chain classifier. But I'm not going to spend too much time explaining this. My goal is to go here and start explaining the interpretability side and what are the challenges evolved from it. So I'm using SHAP. SHAP is an interpretability technique that comes from game theory. So in game theory, where you have n player in your team and you're trying to understand which player is the most contributing factor. So you look into, let's say, the feature I or the particular ith instance of the player, how much his contribution. You look into how much he contributes in separate coalitions, starting from 0-member team to n-1, and you sum it over with some probability weightage. So that's how you figure out how contributing that player is. So over here, instead of game, we have different features that is contributing to the model's prediction. And this below scale in the x-axis, you have SHAP values. So if those cases are positive, then the feature value is predicting that the model is predicting a positive class. If it's on the negative side, it's predicting that the feature is leading to the model to predict a negative class. And over here, you have all the feature label, like the feature values that are binary coded, dummy coded. And those dummy codings are represented in the color bar over here in the SHAP axis. So once we have that, this is for the binary, the question becomes what happens for a multi-label. So multi-label, we have 4 different classes, and I get 4 different sets of these, and you can average this out to get this whole thing. Now, the question is, once you have this SHAP value for a particular feature, each dot represents a particular patient. So what does that mean for whether this particular instance also predicting MV or ICU? That is not very clear, or you can parse out by looking at one of these SHAP values. So one approach is average. I don't know how feasible or right way to, but it's a path. I'm just showing you that this is an approach that we try to tackle. And the way we tackle is that when you generate a SHAP explainer, which is like SHAP.explainer, you instantiate, and then you run it on the X-train, how the model is predicting. You get 3 instances: SHAP values, base values, which is the model expectation, and the feature values, which is the feature on you train the model. And you can average it out across 4 different classes for the base values over here. And you can also do it for SHAP values, and then by pulling out SHAP values from the explanation object. And then you see the plot over here. And over here, this is the bee swarm plot that looks at each individual feature levels and the plots. So now the question is that whether is this a feasible route or not. And the last thing is that this is our team. And thank you.
Thank you very much. Thank you. I'm going to go ahead and say if you have slide transitions, we're going to make you spin the wheel. All right. Tim, you're up. Come get hooked up and start spinning. UV, you're next up. And next in the on deck seat is Kelsey Jordal. Sorry in advance when I butcher all of your names. I apologize. Kelsey, is that who's?
Yeah.
Fantastic. Great. Spin the wheel. Spin it. Ooh, that's a -2 right there.
All right.
Remember, if you want to, you can make an animal noise. So.
Do you want a minute back, Tim?
I wouldn't mind an animal noise.
Okay.
Sing the talk.
Any animal noise suggestions, folks? Anyone? Frog? Frog it is.
All right.
It better be good.
Frog sound.
In the
My-
middle of like the talk. Though.
In the
Yeah,
okay,
yeah.
I'll
Not
mix
the
it
beginning,
in
not
there.
the end. In the middle.
Okay, here we go.
He's getting 4 unless a frog noise doesn't happen. So yeah.
All right.
Take it away.
Cool. Well, I'm Tim Swenya. I'm a software engineer at Google in Chicago. I work on a product called BigQuery Data Frames, and we're going to use that a little bit today. If you want to follow along, I got some links. This notebook's on my personal GitHub. Still using my former last name on there, so T-Swast. So today we're going to take some unstructured data, so in this case, recordings from 100 years plus ago that are available for free on the U.S. Library of Congress. They call it the National Jukebox Collection. So I downloaded a few of those. We're going to play around with it. And we're going to play around with some cutting edge tech today. Ribbit. So we've got, we're combining a few things here. So we're processing audio. So we're using these multimodal models that can handle text, audio, video, everything. We're going to try and search through that. So we're going to use those models to create embeddings to find semantic meaning in all that. And I'm not going to write SQL, even though I'm using BigQuery, which is mostly SQL. I'm going to use BigQuery data frames to do this all in Python. If you're not familiar with BigFrames, which you probably aren't, it's an open source package available on SciPy called BigFrames. You got to do a little bit of configuration. The features I'm showing today, you can use the free trial, but not the free tier. So you do need to provide a credit card in order to use the AI features. But BigFrames can read from all sorts of data sources. Here I'm reading a line delimited JSON file that's stored in cloud storage. We provide a bunch of wrappers to different file formats, also BigQuery tables. So you can see here we've got 300 rows that of data I downloaded. There's I think 16,000 in the actual data set, but I figured 300 is probably enough. It's over a gigabyte of MP3 data. I'm processing it a little bit here, and then here's where the magic starts. So I'm creating a pointer from this data frame to those GCS files, those MP3 files, and then I'm telling Gemini to transcribe those files into text. And you can see down here, we get kind of the structured blob back with our transcriptions. It's always good to double check that everything transcribed. In this case, all 300 rows got a transcription. And here's some example of those song transcriptions. One thing to note here, so we do have English, but there's also other languages in here. I think that might be Russian down there. So the multimodal model is very flexible in the data you provide it. I won't try to play audio today, but you can from the notebook. And so we have this data, we have these transcriptions. How do we search it? So we create our embeddings. So an embedding is just like some abstract vector representation of whatever the LLM model considers the meaning to be. It can't give us an embedding for empty strings, so we filter those out. So created our embeddings. We did that in bulk. You could do that for a whole bunch. And then to search, you create an embedding for your search string and then find the nearest one. So here I search for.
Thank you so
stuff to
much,
do with a farm.
Tim. Thank you. A big hand of applause. All right. You can come up and start getting set up. And next to come up here is Ryan Abernathy. Ryan, are you in the room? Yep, great.
I have the HTML.
Yuvi, would you like to spin the wheel? And also, do you have any slide transitions?
I do not have slide transitions, and I've already spent time with Paul today, so no more punishment from me.
I don't think that was called for. But that's fine. All right, take it away. It's all yours.
Okay. Ooh. Did I?
Oh my.
Oh, I did sing.
My. Oh,
That's not a lightning
my.
talk. That's a lightning
It was-
song.
The council has
I am
decreed, spin the
terribly
wheel.
sorry. All right, 1 minute off. You've got 4 minutes.
That's
Take
fine.
it away.
I can do that. I will also do an animal noise. This is the end of the slides. No, I'm lying. You do not need to contribute more to open source. If someone says you'll feel better after you make one more PR, that's like one more cigarette before everything is all right. So don't fall for it. I lied, I have more slides. It doesn't apply to everyone, but it definitely applies to more people than you think. Only you can tell if it applies to you, or your therapist can tell you if it applies to you. It can be hard to access, especially if you live in the US, so I will just apologize for that, even though it's not my fault. Open source can be a great way to find community. I think that is why we're all here, but it should not be your only community. That is too much pressure to put on any community, especially one like this that is a mixture of professional and personal ones. So don't do it. It will not end well. Your collaborators cannot be your only support system. They cannot be your only friends. Some of them can be your friends. They are all friendly to you if you're nice to them, but they're not your friends by default. You need to make friends outside your open source collaborators. You need to have other friends who do not know what Python is. You really do. Being emotionally regulated will make you nicer to work with. I want to work with more emotionally regulated people, which is why I'm doing this now. So this is all really just selfish, ultimately. It will also make your life better. You will not be stressed doing things. Therapists can help you learn the skill of being more emotionally regulated in the same way you can learn programming language skills and code review skills and communication skills. You can learn emotional regulation skills. It's not something you're necessarily born with. You can learn it, and you should learn it. In a world that feels very out of control, you may think that controlling the quality of code may make everything feel all right. If any of you have been in a really long, protracted, extremely pedantic code review session on a particular PR that has been going on for far longer than it should, this is often why. It will make things better for a really short time, but no, just don't. I did do this. I've been less present in open source communities for a couple of years in the middle. After, I've had a lot of overnight project creations, overnight feature additions, overnight bug fixes. They helped me a lot, and then eventually they didn't. You finish the thing that you think will make you feel better, and it doesn't. And then you think, oh, something is off. Maybe I'm now broken. Maybe I need to make a bigger PR or start a bigger project, it's like violence. You're not using enough of it. But it doesn't, it is a coping mechanism that helps a lot, but no. So stop. and do go to therapy or find other ways to be better emotionally regulated than otherwise. And as a bonus slide, do not start a new project to recover from burnout. It does not work. It just does not work. All right, thank you.
Thank you, UV. If anyone feels attacked by that, we'll have a support group on Friday.
Ryan, can you please come up to the front to
Ryan,
get on deck?
no, Ryan, you're over here. You're next. Sit over there. And Kelsey got to spin the wheel. And next up on deck is Tetsuo Koyama. Tetsuo Koyama. いらっしゃいますか?
Sorry.
はい。あそこへ行って座ってください。
Yep. I got a spin.
Yeah. All right, so just spin down.
Yep.
Tiny
Good.
hands.
Sorry.
All right, that's excellent
Tiny
news.
hands?
So a hoodie for the effect. So
We take this very seriously.
just
Sorry.
it's just
Regular?
Yeah, you're putting it on backwards, but just put this hoodie on like normal.
Okay.
Yeah.
I thought you were putting me on.
No, and
Okay.
then.
All right.
And then
Here it comes.
hands shrunken.
Yep.
There we
Yeah.
go.
Okay.
Just like riding a bike. You never forget.
All right.
Okay.
So, move on.
All
Take
right.
it away.
All right. All right, I'm going to talk about floating point values, and in particular, NaN numbers. All right, so most people here probably know what a NaN value is. This is a diagram of the bits contained in a floating point number. This is a double precision 64-bit float value. There's one sign bit, there's 11 exponent bits, and there's 52 significand or fraction bits, right? How do you mark a NaN value? A NaN, by the IEEE 754 definition, has all of the exponent bits set to 1, and at least one of the significant bits set non-zero, right? That's all it has to be. It has to be at least one of them because otherwise that distinguishes it from an inf. Now, that means there are a lot of bit patterns that can signify a NaN, right? So if you call math.nan or numpy.nan, you get a particular NaN pattern or bit pattern back as a NaN. There's just one. But there are many, many more, right? There are 51 free bits in your double precision value. That is sometimes called a payload, right? So you could put values there. Not many people do. They should be propagated by operations generally and preserved. There are also quiet and signaling NANds. I won't talk about those. I'm interested in this payload. Okay, so there is a definition for using the payloads in the most recent revision of the IEEE 754 standard a few years back, 2019. This is in the C language. It's in the C23 standard, and it's in glibc, but it's not in Python, and it's not in NumPy, right? So set payload and get payload functions are supposed to be, or are maybe declared by a language implementation. All right. But what can you do with NumPy? To NumPy values, okay, now we gotta do this live. Let's see, there. So NumPy, there we go. If you look at the particular NaN value that NumPy produces, np.nan, it has this this bit pattern. It has the all of the exponent bits set and the most significant of the fraction bits set. Everything else is zeros. The sign bit's 0. This is what it looks like. So now I can use that. Anything that has that pattern, no matter what the other things are set, is going to be a NAND. So what can we do? I make a random array here of NumPy integers. All right, and now I bitwise OR that with the NAND value. And then I get a bunch of different integers, okay? Let me shrink this a little bit. All right. And those are all still NANDs, right? Turn that back into a floating point value and they're all still NANDs. But the payloads are in there. They're different NANDs. They're not the same NAND anymore, okay? Neat. What else can you do with that? Well, let's make a library that can do this. Now I can take this, hide integer values in floating point arrays. Okay, here's another random thing. Okay, here we go. Can I recover that? Turn integers into NANDs, recover it. It works. All right.
Thank you so much.
All right.
Thank you, Kelsey.
There. Thank you.
That was really good.
Missed an open goal with NumPy there, but that's
Plenty
fine. Ryan, you've never given a lightning talk? Are there slide transitions?
There are. Maybe no, there's not slide transitions.
I don't know about that.
I'm making my lightning talk interesting by doing it on extremely low battery.
Okay, no,
That's
that's
how
great.
I'm
No,
keeping
that's
this.
wait, okay, we're following the drawt boom protocol. Everything is okay. All right, and next up on deck is Filippo Balzaretti. Yeah. Filippo? Yes, all right, please come up here. Thank you very much. And take it away when the screen comes up, I guess. Close? So close. If I am, this does feel a little bit like Matplotlib 3.0 lightning talk. I'm getting that vibe.
Can you not see
You
it?
should look that up online if you haven't seen it. One of my favorites. Okay, fantastic. Take it away, Ryan.
Okay, great. Oops, there we go. Okay, I'm really excited to talk I've heightened my excitement by doing this on very low battery, so I'm even more worked up to share this new project we've been working on at Earthmover. It's called IceChunk. It is a new open source transactional storage engine for ZAR. That's a mouthful, but I'm going to explain what it is and what it enables. So first of all, this is all about how we store multidimensional arrays, aka tensors, in the cloud. And our view at Earthmover is that tensors or arrays are a really important data structure throughout science and scientific computing, but they're not as well supported as they should be in cloud data platforms and infrastructure. So raise your hands if you work with arrays in your work as a data scientist or a practitioner. Fantastic, me too. They're used throughout this space, obviously, and I don't need to convince you how great they are. One problem that we've had in our community is that a lot of the archival file formats for array storage kind of struggle to work well in the cloud. So I'm talking about things like HDF5, NetCDF, GRIB, what I mean is these file formats, if you're going to use the cloud, you're going to put data in cloud object storage. But these archival file formats weren't really meant to be read from object storage, meaning you have to make a lot of these HTTP calls, and it leads to really slow performance and frustrating workflows for folks who want to do array-based data analytics in the cloud. And so a solution to that problem is ZAR. This is a library that you may be familiar with. It's a NumFOCUS sponsored project, and it allows us to store arrays of any size by sharding them up, storing them in separate objects, and we can read and write them in parallel, and that's awesome. Who uses ZAR today? Okay, cool, we got some ZAR users in the room. But as people started using ZAR in cloud object storage, we noticed a new problem, which that it's not really safe to use in what we call multiplayer mode. ZAR as a format, it doesn't support the sort of consistency and transactional sort of guarantees we would expect from a database. Meaning if one user was reading from these ZAR arrays while another user was writing to them, they could see all kinds of corrupted or messed up or wrong data situations. And so to solve this problem, we have created the IceChunk project, which is a transactional storage engine for ZAR. So I'm going to explain what it does, but the main features of IceChunk is that it provides true ACID transactions for ZAR storage, but it does this without any server in the mix, without any locking, just by purely using the object store and its consistency guarantees. This allows you to do data version control, so branching, tags, rolling back, time travel on your arrays. And it also has this virtualization capability so that you can layer it on top of existing NetCDF or HDF files and get these capabilities without having to transform all your data to a new format. So it kind of works by sitting in between ZAR and object storage and mediating the requests between the ZAR library and what's stored in the object store. And so if you're familiar with this ecosystem, it kind of replaces FSSpec and S3FS and takes over the I/O involved. And so what IceChunk basically allows you to have is the full ZAR or HDF data model. You can have groups, you can have arrays, you can have metadata, but then you have a full sort of version history of how that is updated. So you can kind of think of it a little bit like Git meets HDF or ZAR data model. This also allows us to do branching and tagging workflows within this data set. So think about for example, a machine learning models workflow. You could evolve your data set, you could tag it, you could update it incrementally without having to generate a bunch of new files. IceChunk is also very fast. The I/O layer, all of it was rewritten in Scratch, from scratch in Rust, and so it enables really, really high performance I/O saturating throughput in a cloud context. So this is some results from a pilot we did with NASA where we were able to speed up a data analysis workflow by about 100x. So if you use multi-dimensional array data in the cloud, come talk to us. We got a booth out there, and we're dropping 1.0 tomorrow.
Thank you so much, Ryan. Thank you. Tetsuo, you can come up and start getting set up. Further evidence that all software is either a database or a compiler. He's there. Okay, great. And then I think probably our last person for on deck for the evening, Katrina Reel. Katrina, are you here? There she is. Fantastic. Please come up. Spin the wheel. Spin the wheel. Tiny hands. Hope you're not typing a lot. Although it's easier to type with the hands than it is with the lobster claw. I did not make the wheel. There are 2 tiny hands entries, I should say. So that is part of it also. All right. Is almost outfitted? All right, here we go.
So I want to introduce my Sphinx extension deck. How many people are using Sphinx? Please raise your hand. Yeah, a lot of people are using Sphinx extension. Today, I want to introduce 2 extensions which my friend is made. And one is Sphinx Reveal.js. This extension is to make a slide from Sphinx source. And this is an extension to build Reveal.js presentation. And the feature is convert section from restructured text directory to the Reveal.js slide and support customized sections and support using plugins and etc. The thing you have to do to introduce this is only pip install Sphinx Reveal.js and set up to the extension in the config file. And if you write the source, you can convert it to the Reveal.js like this and make a slide like this. Okay. And the second one is the Sphinx Neko-chan. And this is the Sphinx extension for adding the Neko-chan, which is the cat in Japanese emoji to document. And this is a extension which Takenori, or my friend, is made. So you can install this, only people install Sphinx Neko-chan and add the extension to the config file. And if you write it to the REST Neko-chan Banzai world and Neko-chan OK and Neko-chan beer, it is converted to the Neko-chan's emoji, and you can customize a slide like this. And there is a lot of Neko-chan's emoji to this library, and if you can make a Neko-chan of the bear, you can create like this, and Neko-chan with a hot spring, and Neko-chan with rice bowl, and Neko-chan with LGTM. And you can also rotate emoji and 90 degrees, and Neko-chan Yoshi emoji to the right and the left. And the license is the MIT, but please follow the license of the Neko-chan's emoji, which created by the Japanese creator. And please enjoy the Neko-chan's emoji. Thank you.
Thank you very much, Tetsuo. That was fantastic. Filippo, would you like to spin the wheel of pain, or are you? It's up to you. Oh, great.
Yeah, but before we do this, just so that we don't announce it afterwards, in 6 minutes, we're going to have the virtual poster sessions be starting on Gather. So go ahead and check that out if you, people should check that out. That's starting at 1800, 6 p.m.
That's okay.
Spin the wheel.
Yeah.
The guy's game for it. I should also say, one of my jobs here is to be an agent of chaos, but I want to clarify something. If I approach the stage during your talk and it's early, I'm trying to help. I will not hurt you. I think there was a flinch when I was fixing the mic. I just want that to be clear. The chaos comes at the end and the beginning. In the middle, we're hands off. So I just want everyone to feel safe up there. My apologies.
Yeah. That's a -1 minute penalty, so you have 4 minutes.
Right. Take it away.
All right. Hello, everyone. My name is Filippo, and this year I am turning 33, but that doesn't mean I can't be a huge, proud Pokemon fan, especially for the competitive part of Pokemon. And I am such a fan that back in 2021, I guess, together with my Italian Pokemon community, we created this website, the Eldas League, where people can go, and it works more or less like a interactive forum where you are basically simulating the video game features. So you go and collect the badges, but the gym leaders are actually real people who know how to play, and they are very hard to beat. So if you want, you can check it out with the QR code, but I think you will have to learn Italian first. Now, here's the thing. This website was built based on WordPress, and inside there's a lot of HTML, CSS, and JavaScript. And for that, I had to harass pretty badly my brother, who is a web developer, to ask him to create his website for free. And also other friends of mine, like Martina, who also knows how to use these codes. And I have no intention whatsoever to learn how to use these 3 codes. So where is Python? Unfortunately, with my Python skills, all I could do was to generate strings for the gigantic Pokemon database, which counts now more than 1,000 Pokemon. And these strings were helpful for the website itself, and also to generate CSS code, actually. So I would just like to be very, very brief here and say that this lightning talk is actually a request for help for everyone in the room who is Pokemon passionate and who can let me know how I can use Python to interface Python with WordPress. For example, something I wish I could do is translate the website from Italian to English so everyone can actually enjoy it. Or we actually also have developed an API that uses Python that interfaces the website with Pokemon Showdown, that's the battle simulator, but it doesn't work. And I would also like to understand how can I use a website like GitHub to make this project open so that people can contribute and help out. Because something I've learned in this conference is that there's literally nothing that Python can't do. Thank you.
Thank you very much, Filippo. I think that was your name. I lost track of thing. And next up is Katrina.
And Katrina's going to be closing our lightning talks for today.
Two minutes off. Ooh, that's rough.
Yeah, or if you give us an animal sound, you get a minute
We
back.
can make a deal.
Right.
Yes, that's an acceptable
I brought my own
compromise.
prop because I was expecting something to happen here. Wait.
This works.
All right.
But also, please make a shark noise during your talk.
Yeah.
Okay. I am also, by the way, blind as a bat, so I actually have to like move to my
Yes. Okay,
slides
that's fine.
first.
If you switch between both pairs of glasses periodically, we'll allow that as well.
Yeah, here we
Oh,
go.
yep, perfect. Higher, higher.
On top?
Yeah, excellent.
Okay.
Yeah, good.
All right. Do I still need to make an animal noise?
Let's say yes.
Okay. What do y'all need? Donkey?
We heard donkey. Donkey it is. Okay.
Donkey. Yeah.
And we started
And
the
the
clock 10
timer's
minutes ago.
running.
All right, this is going to be the saddest donkey you've ever heard. All right, so I'm Katrina Reel. I'm on the CUDA Python team over at NVIDIA. You may have noticed there are a few NVIDIANs walking around just a little bit. And why are we here? It's because we're doing a lot of work over on the CUDA Python space to make Python a first-class citizen in the CUDA ecosystem. So trying to make GPU computing a lot more accessible and a lot easier for people to use. But when you're looking at this, generally you think about like you get the most performance when you get a little bit lower down into the hardware, and as you move up the stack in levels of abstraction, you may lose some performance. But our goal as we move through this is that we want to push this out so you can get that abstraction and the expressiveness without losing any kind of performance. So you can get as close to speed of light as you can possibly get as you're working with your GPU. And this is, I kind of went back on this, but what are people interested in doing? Okay, so hee-haw, yee-haw. All right. So where do I start? A lot of people want to try and use a GPU, and there are several points of entry if you want to use CUDA. So it's under the hood on a lot of libraries. And the one that I'm constantly telling people is that if you do use NumPy, which I'm pretty sure everybody does in the scientific stack, you have a drop-in replacement with CuPy. So that is a drop-in replacement for both NumPy and SciPy. So a lot of times you can just change the import from NumPy to CuPy and it'll work. With very, very few changes that you need to put in there. So you can get that first taste of GPU acceleration, and then we got you hooked, and then you're going to have to learn more. All right. And so, but similarly, you may have heard of Rapids. So if you do use Pandas or scikit-learn or anything like that, you could move over to the Rapids land. So we have cuDF, we have cuML, and if you're a NetworkX user, we have cuGraph as a backend on that as well. But saying that, a lot of people ask me about CUDA kernels. What are we going to do here? And as part of trying to use native Python in order to create CUDA kernels, we have, a lot of things that are coming out over in CUDA.core. There are, the CUDA.ccl libraries are coming out. Some people probably saw Bryce's talk about Qtile. There are a lot of different paths to writing a kernel over on the Python side. And I just want to stress that not to get too wrapped up in it, because CUDA fundamentals are the same no matter which one of these frameworks, no matter which one of these DSLs or anything that you're using. So if you understand the programming model, if you understand the memory model, you'll be able to translate that over and be able to use it in any of these. So use the one that works the best for what it is that you are working on is the most expressive way for you to get your work done. Okay? All right. With that being said, I love to give stuff away. So over on the Accelerated Computing Hub, if you want to check this out, I had released this right before SciPy last year, and it has a whole bunch of educational materials in here. If you are interested, all of the notebooks from the tutorial on Monday are available in there, and you're welcome to them. Also, if you're also just, I don't know, a masochist or something, you can try the C++ tutorial that's in there, which, believe it or not, is in Jupyter Notebooks, by the way. So definitely check that out. Another thing that I have going on, I have this virtual Connect with Experts once a month. I have basically a virtual meet people from NVIDIA and talk about different stuff. And don't come near me with that claw. And we're going to do CUDA Quantum next and get a free course from DLI. All right.
Thank you very much, Katrina. Thank you. Okay, that concludes the first day of lightning talks. Thank you everyone for coming. Now at 6 p.m. in this room, you're already in the right place. There's a poster session from 6 until 7. You should please look at the posters. People worked really hard on them. Like, there's no joke there. And we're going to have a quick announcement from this.
Hi, everybody. I'm Andy from NVIDIA. I'm just here to welcome everyone to the social that we're proudly hosting at the Glass Museum. Different museum than last year. So don't go to the Art Museum. Go to the Glass Museum. Just go down the road, make a few turns, follow Ed. He'll get you there. Come see us for some glass exhibits, enjoy refreshments, and meet your fellow SciPy attendees. NVIDIA will have some folks in NVIDIA t-shirts. We'd love to chat with you about anything, about our magic math boxes, about why we don't need the hot shop because we're cooler than that, and we can water cool things and handle that sort of thing. But we're going to be in the other part of the museum tonight, and so with some really amazing glass. If you weren't there last year, it's probably the best museum I've ever seen as far as like really glass museums go or like amazing art. So yeah, that's all we had. Thank you very much. Thank you, SciPy, for being such a great conference.